we consider the process of choosing a committee of 3 from among 5 people. We can reason this out by noting that there are 5 choices for the person that's chosen first, 4 for the second, 3 for the third. So there are 5 times 4 times 3. But this is for people chosen in order. So there are 5 times 4 times 3. That comes out to be 60 possible ways to choose 3 people out of 5 in order. However, a committee isn't ordered. So since there are 3 times 2 times 1 ways to order each possible committee, and all those ways would be included among the 5 times 4 times 3, or 60 ways to choose 3 people in order, we have to divide the number of ways of the number of ordered choices by the number of possible orderings of each committee. So we divide 5 times 4 times 3 by 3 times 2 times 1. The 3 divides the 3. The 2 divides the 4, leaving us 2. We end up with 5 times 2, or 10 possible committees. Now, we've already seen previously how we could do a tree diagram, a listing, etc., come up with the same idea. But of course, a tree would come up with 60 possibilities here, and they would be grouped in 6s. Each group of 6, or 3 times 2 times 1, which is 6, would constitute the same people on the same committee. Okay. Alternatively, now we've talked about permutations and combinations. We see that what we're doing is we're choosing 3 out of 5 with no replacement. And I should write no replacement in here, in which the order doesn't matter. So the number of ways to do this is what? It's the combination. Combination 3 out of 5. 5C3, 5 factorial over 5 minus 3 factorial times 3 factorial. Now I can write that out. That of course equals 5 factorial over 2 factorial, if we keep it in order, times 3 factorial. And that comes out to be 10 if we write it out and do the cancellation and so forth. But I chose to write it this way just to relate it to what we have here. So 5 minus 3 is 2, so 5 minus 3 factorial is 2 factorial. We still have the 3 factorial. We've written the numerator out, 5, 4, 3, 2, 1. And now I'm going to write the 2 factorial as 2 times 1. And we're just going to look at what this part of the expression tells us. And we see that this part of the expression gives us just 5 times 4 times 3. Now, then we're going to have 5 times 4 times 3 divided by 3 factorial. And we write that out. And we see that this is the same expression we had over here. Now, the significance of doing it that way is this, 5, 4, 3, 2, 1 divided by 2 times 1 gives us the 5 times 4 times 3, which is the number of ordered choices. And then the 3 factorial is the number of ways any selection of 3 could have been ordered. So this is the same as this, but the connection is kind of hidden in all the notation here. Okay, so if we write it out this way, we kind of miss that connection. Still, once you get this and write this out, it's easy to evaluate, and you can simply proceed to do so. Again, though, I recommend that you understand how to do this both ways, that you understand all the reasoning here, and that you understand how to identify and evaluate a combination.